Hi everyone, I am Shomoji Chakraborty, a PhD student from the Life Lab at Vanderbilt University. Today I am going to discuss about a brief overview of my research proposal, which is effects of asymmetric locomotion methods on collaborative navigation and wayfinding in shared virtual environments. Let us suppose that a group of people wants to travel to a place from their current location. So what will they do? They may form a strategy about the route to the destination first. Next, they can use a form of locomotion to move. They may update their route strategy while navigating because of various reasons like traffic jams, roadblocks, etc. And thus, they will reach to the destination ultimately. This overall process can be termed as collaborative navigation and wayfinding. For example, many a times we can see that a passenger can guide the driver of a car by following a map or any form of instructions of the intended route to travel from one place to another. Given that people often perform collaborative navigation and wayfinding in real world, I want to see how people can collaboratively navigate and wayfind in a virtual environment in general. Now, while considering multiple people in a virtual world, we face two important questions among many others. That is, how do people experience the virtual world collaboratively, and how do they locomote through the virtual world collaboratively? To experience the virtual world collaboratively, the environment can be shared among all the people so that they can experience the same environment at the same time. However, answering the second question is difficult because all the members of a group may use either a symmetric locomotion method such as joystick or teleportation, or each one of them may use asymmetric or different locomotion method such as joystick with redirected walking. There has been a significant amount of research in collaborative tasks in terms of locomotion methods, interaction, spatial learning, effects of leaders, avatar interaction, presence, and much more. However, if we consider the locomotion methods in general, we will find that all of the previous studies are based on symmetric locomotion methods. To my knowledge, there has not been any prior research done in the field of asymmetric locomotion methods. So, given from the prior literature that different locomotion methods affect acquired spatial knowledge differently in virtual environments, and dyads perform better than individuals in acquiring survey knowledge using symmetric locomotion methods, I want to see through my research how do different locomotion methods affect the acquisition of survey knowledge for collaborative navigators in a shared virtual environment. To find out the answer to this big question, I will set up 3 consecutive experiments to answer 3 research questions, which I will be discussing shortly. In each of my experiments, I will use the virtual maze environment by Crastil and Warren's acquisition of survey knowledge experiment. I will change the maze slightly to test individuals and multiple people. People need to walk through the virtual mazes to remember the locations of various objects placed at various places in the mazes during the training phase. During the testing phase, people will be placed in an empty desert environment, which will be free of any cue from the virtual maze environment to estimate the direction and the distance of one object from another. So, the main independent variables of my overall research are different locomotion methods and number of objects to learn in the maze. And the main dependent variables of my overall research are angular error, distance error, and recall time, as previous research used these variables as the metric to measure survey knowledge of individuals or dyads. Let's discuss about the first research question, which states if a locomotion method performs worse than another locomotion method for individuals, will it still hold for dyads? This research question will establish a basic understanding of the effects of 2 asymmetric locomotion methods on dyads in collaborative navigation. To answer this question, I will choose 2 different locomotion methods, that is, joystick with body-based rotation and resetting. Using these 2 locomotion methods, I will compare the acquired survey knowledge of individual navigators of a dyad with the overall acquired survey knowledge of the dyad as a unit. Now, there are mainly three reasons for using these two locomotion methods. First, I want to use physical walking as the constraint between these two chosen locomotion methods, as people do not physically walk in joystick locomotion method, whereas in the resetting method, they physically walk. Second, as previous research showed that dyad acquire survey knowledge better than individuals using joystick with body-based rotations, I chose this locomotion method as one of my test methods. And finally, I chose resetting because it can be the closest real walking simulation performed in our lab space. The two main expectations that I am willing to see from this experiment are that dyads perform better than individuals using asymmetric locomotion methods as well, and symmetric joystick performs worse than asymmetric locomotions, which performs worse than symmetric resetting, where the latter represent the locomotion methods used by dyads. The second research question checks if a generalized hierarchy of locomotion method performance exists in case of individuals. Does it still hold for dyads in terms of acquiring survey knowledge? To answer this question, I will introduce walk-in-place locomotion method along with the other two locomotion methods that are used in research question 1. And like research question 1, I will compare the effects of these locomotion methods on individuals and dyads in terms of acquired survey knowledge. The main reason for introducing walk-in-place is that it is a form of hybrid locomotion method where people need to simulate physical walking while standing at the same place. Finally, as previous studies showed that joystick performs worse than walk-in-place and walk-in-place performs equivalent to resetting for individuals, I expect that this relationship will hold for dyads as well. The third research question states, if there are more people in a group rather than two persons, will the previous findings still hold? The main reason for checking the effect of asymmetric locomotion methods on increased group size is that presence of a leader in the group can affect the overall group performance, which has been shown in several previous studies. To answer this question, I will use the three locomotion methods that I used before to answer research question 2. And this time, I will compare the acquired survey knowledge of triads using symmetric locomotion methods with the triads using asymmetric locomotion methods by each one of them. I expect two main findings from this experiment, which are, if there is a leader and he or she uses an inferior locomotion method, the overall group performance would decrease and vice versa. And lastly, if a certain locomotion method performs worse than another one for dyads, it will still hold for triads also. Overall, using three research questions, I would like to investigate the effects of asymmetric locomotion methods on collaborative navigation in a shared virtual environment. I would like to thank our sponsors to support my research. I would like to thank you for listening to me. If you have any questions, I am happy to take them now. Thank you.